Welcome to this lesson on parallel circuits. In this video, you'll learn about circuits that provide multiple paths for electric current to flow. Parallel circuits are fundamental to understanding how electricity works in our homes, cars, and electronic devices. A parallel circuit is a circuit configuration where components are connected in such a way that electric current has multiple paths to flow from the power source to the load. The key characteristics are: first, current divides at junction points and flows through different branches. Second, each branch operates independently, meaning if one component fails, the others continue to work. Third, all components connected in parallel share the same voltage across them. Let's compare series and parallel circuits. In a series circuit, components are connected one after another in a single path. Current has only one route to follow. In contrast, a parallel circuit has components connected across common points, creating multiple paths for current. This branching structure is what makes parallel circuits so useful in practical applications. In parallel circuits, current behaves in a specific way. When current reaches a junction point, it divides and flows through the available branches. The total current entering the junction equals the sum of all currents flowing through individual branches. This is expressed mathematically as total current equals current 1 plus current 2 plus current 3, and so on. This principle is known as Kirchhoff's current law. One of the most important properties of parallel circuits is that voltage remains constant across all branches. The voltage across each component is equal to the source voltage. This means every component receives the full voltage supplied by the battery or power source. Whether you have 2 branches or 10 branches, each one experiences the same voltage. Calculating total resistance in parallel circuits is different from series circuits. The formula is 1 divided by total resistance equals 1 divided by resistance 1 plus 1 divided by resistance 2 plus 1 divided by resistance 3, and so on. 2 important facts to remember. First, the total resistance is always less than the smallest individual resistance in the circuit. Second, adding more branches actually decreases the total resistance. Let's work through an example. Suppose we have 2 resistors connected in parallel. One is 6 ohms and the other is 12 ohms. Using our formula, 1 divided by total resistance equals 1 divided by 6 plus 1 divided by 12. Finding a common denominator, this becomes 2 divided by 12 plus 1 divided by 12, which equals 3 divided by 12. Taking the reciprocal, we get a total resistance of 4 ohms. Notice that 4 ohms is less than both 6 ohms and 12 ohms. Let's review the key properties that make parallel circuits special. First, each branch operates independently of the others. Second, if one component fails or is removed, the other components continue to function normally. Third, each component receives the full source voltage. And fourth, current divides among the branches based on their resistance, with lower resistance branches drawing more current. Parallel circuits are everywhere in our daily lives. In household wiring, all electrical outlets and lights are connected in parallel, allowing each device to operate independently at the same voltage. In automotive systems, headlights, radio, and air conditioning work on parallel circuits. Battery banks use parallel connections to increase current capacity while maintaining voltage. Even computer components on a motherboard share the power supply voltage through parallel connections. Let's summarize what we've learned. In parallel circuits, current divides among the branches. Voltage remains the same across all branches. Total resistance decreases as you add more branches. And most importantly, branches operate independently, which is why parallel circuits are essential for modern electrical systems. Understanding these principles will help you grasp how electricity flows in the devices and systems you use every day.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.